Okay, so another weird but enjoyable substitution here. You'd think it wouldn't make much difference if we substitute x for negative u, but there is a reason behind this madness. So if we make x equal minus u, we differentiate, we get dx equals negative du. All right, let's look at the limits. So the limits, okay, so let's just go straight to here. We've got minus 2, 2, we've got x squared on e to the x plus 1 dx. So if I change the limits to u's, when x equals minus 2, u will be 2. When x equals 2, u will be minus 2. If we look at what x squared is, so if I square this x squared, I'm going to get u squared. So this becomes u squared. I'm going to get, instead of dx, remember I'm putting in minus du, so I'll put a minus out the front, so dx becomes du. And on the bottom I'm going to e to the x, so x is now minus u plus 1. Okay, what I can do there is also multiply by e to the u on e to the u, so I'm multiplying by 1. Just to get the bottom back to 1 plus e to the u. So let's have a look at how that happens. So you can see here that I can get rid of this minus out the front by just changing my limits, swapping them around. Minus 2 to 2 instead of 2 to minus 2. All right, now if I multiply everything here, I've got e to the u and u squared du on top, but on the bottom, e to the minus u times e to the u is 1, and then I've got e to the u here. And it doesn't matter what letter I use, this is equivalent to minus 2 to 2. I'll just change everything to x's. That'll be x squared, that'll be dx on 1 plus e to the x. All right, so you can see I've written it in a weird order, but it's exactly the same as that. So if I'm going to use that here. So we've proven this first part, that is true. So now if I go back to this original, was that the original? Yeah, that's the original. And I don't really need that anymore. I'm going to put the original over here, so I've got more room. So the original integral, these are the same. So if I just want to integrate this, I can actually, if I add these two together, I'm going to have 2 of the original integral, right? So, or think of it as 2 integrals, is I'm going to add these 2 different versions, and you'll see why in a second. So 2 times the integral would be that, with respect to x, plus this one. I'll rub this out, so I'm adding them both. So plus this one, x squared e to the x on e to the x plus 1 dx. So that's 2 lots of the integral. So if I want 1 lot of the integral, I'm just going to put a half out the front, right? So half outside. Now they're both from minus 2 to 2, so now I'm going to put them together. And you can see they've both also got an x squared term, so I'm going to factorize by that x squared term. So there's 1 plus e to the x, and on the bottom they're both e to the x plus 1. Alright, now you can see why these 2 things will cancel. So you've just got the integral of x squared, right, which we know is x cubed on 3. So x cubed on 3 between minus 2 and 2. So I'm just actually going to put a 6th out the front. When I sub 2 in, I get 8 minus, when I sub minus 2, I get minus 8 in there. So I actually got 16 on 6. 16 on 6 is the same as 8 on 3. So the integral would be 8 on 3. So that's a weird way to use 2 different versions of the same integral and add them together.